Okay, as promised, Form A, 15, 16, 17. Here we go. All right, to do f of g of x, I'm going to try to maximize my spots. And I'm whispering because I'm doing this during study hall. My poor students in here have to listen to my voice, but now they know how you feel, right? All right. First thing is you put this in, 3x minus 7 for the name g of x. Then the next thing is, wherever there's an x, you throw in a 3x minus 7 into the f function. So the very next thing you should see is 4 times x. Wrong! 3x minus 7 plus 3 times 3x minus 7 plus 5. I know complaining if you have form B and C. The next parts are essentially the same. You just have to be a good FOILer. Hey, because good FOILers are good factors. And by the way, you cannot distribute that 4. That is illegal in terms of PEMDAS. You must do exponents first before you multiply, which is what's going on there. So that's mistake number one, how we always teach, as I lament in class, why do we make these mistakes over and over again? All right, I'm not teaching foiling. It would be 3x minus 7 times 3x minus 7, which is 3x times 3x, and then 3x times negative 7 twice. And then negative 7 times negative 7. Oh, I hope I could do calculations in my head. And then this is 9x. Here's another mistake. People not changing that x to 3x minus 7. That's a common error. I like talking about common errors. All the years I've taught this stuff. And then distribute. Oh boy, numbers are getting big. 3x squared. Oh, 4 times 4, 160. And that negative 168x. Uh-oh. Okay, my computer scared me. 4 times 50 is 200 minus 4, 196. Hey, giving you a little Samuelus tricks on how to calculate numbers. You know what? That's negative 16. These two added together. Then I'm going to bring it with the 96 and then hopefully get the right answer. That'd be embarrassing if I didn't. All right. And then 36. This is all without a calculator, by the way. So there's my excuse if I don't. And then negative 168 plus 9 is negative 159. I must have said 7. Sorry about that. Yeah. And then plus 180. And no, you don't set this equal to 0 and then start solving and getting x equals. That's not what this says. It just says perform the requested operation, which is simplify. There's no solving going on. Let's move on. Like I said, I wanted this to be quick, and you can always go back and relook at stuff. When I say inverse, you say switch x and y, Mr. Samuelus. All right, and then you get this. Shh, be calm. All right, and then the only way you could get these y's together, like or whatever, is to start and get rid of fractions. Maybe multiply both sides by 6y plus 8, but I'm just going to cross multiply. Again, whispering because I don't want to bother my study hall here. Plus, it's still going to come up. You just turn the volume up and you'll hear me. And then we got a problem. Hey, my 7th grade daughter is doing this a little less complicated, but she is solving for y, and she had y's on both sides of the equation. She didn't have to distribute, so yes, fine. A little bit more complicated, but 7th grade, right? This is why it gets sad, all right? The skills for solving and balancing are old and ancient, and we must reach into recesses of the brain and use those skills to do what we're going to be doing this year. Add 2y to both sides. Subtract 8x from both sides. And I should be able to do that at this point because solving equations is from grade school. So whatever I do to one side, I do to the other. We need to speed it up and move on to, questions like this. All right, now we're going to go here. We're going to pull out that y, and then you get 6x plus 2. That's factoring 101. and then negative 8x minus 7. And then you can divide by that 6x plus 2. All right, very similar steps. Then we'll call it inverse of, is it f? Yeah, always seems to be on there. Call that the inverse of f of x, and it equals, oh, I should have done this. Probably going to be asked tomorrow, what is the domain and what's the range of both the new and the original? Now, you're probably not going to like this, but we had a really good discussion about this in one of the 2 hours about horizontal and vertical asymptotes. And the horizontal asymptotes, I think it was first hour, when these are equal, when we put in a million, this becomes negative 2 million. Minus 7 is irrelevant. What's negative 2 million over plug in a million? 6 million. What's negative 2 million over 6 million? Still negative 1/3. So that is the horizontal asymptote for this. What is the vertical asymptote? Set the denominator equal to 0. Subtract 8 and then divide by 4, which is negative 4/3. So this is what the domain is. Everything but that. This is what the range is. Everything but that. Lo and behold, I know I'm doing terrible notation. That should be negative infinity to negative 1/3, and then negative 1/3 to infinity for the range, and then same thing, negative infinity to negative 4. So look at this. What's the domain of this? Everything not equal to negative 1/3. Domain and range exchange. And what's the range? Well, if you don't get it, it's the domain of the original, negative 4/3. So you could always survive that way. Again, that should be written as negative infinity to negative 4/3, comma, negative 4/3 to infinity. But I've showed you the Algebra 2 way of writing that as well, just so you're used to other books. Then last but not least, we got to stop having problems with this. If I see a parabola crashing through a horizontal line, crashing through a full square root, you're getting 0 points. You've missed the whole lesson, right? And we need to, buck up and listen to this question. So, can I plug in negative 1? No. Will I plug in negative 1? Yes. Negative 1 squared is 1. 1 minus 4 is negative 3, but you put an open dot there because you weren't supposed to plug in negative 1. But you do to start the graph, and then you plug in all the other numbers like negative 2, negative 3, negative 4. Sorry, that's what this means. These are the conditions. So something was missed on a handful of you about how to do this and how to do it without a graphing calculator. If you are using your graphing calculator for this question, you will run out of time and you will probably get it wrong anyway because you're just ignoring my lesson, ignoring how to do this, and really it's fast and easy. Because look, negative 2 squared is 4. 4 minus 4 is 0. So negative 2 comma 0. That's it. You should know it's a parabola. I don't need anything else. You might have a nice little coordinate there if you plugged in negative 3. Fine. Negative 3 squared is 9. 9 minus 4 is 5. 1, 2, 3, 4, 5. Oh, I nailed it. Nice. So excited. But it stops. It doesn't keep going. All right. Down to negative 4 and then having a full parabola. You graphing calculator copiers. This is, you either listen or you don't. I'm moving on. I'm already frustrated. All right, and then this is a graph. I'll even color code this. This is a graph of a horizontal line, but you graph it from negative 1, close dot, because it says I can plug in negative 1, all the way up to 1, and I can plug in 1. So that's a closed dot as well. I hope I say closed. I might have said opened on that, but it meant closed if I said it. You see it's closed, so I'm fine. And then change colors. This is a square root graph. Should I plug in 1? Yes. Just make it an open dot. 1 minus 1, 0. And can I? Yes. Square root of 0, 0. 0 plus 2 is 2. So 1 comma 2. Careful. Oh, I'm real shaky here. All right. Whew. And then I plug in 2. Square root of 2 minus 1 is 1. Square root of 1 is 1. 1 plus 2 is 3. So 2 comma 1, 2, 3. This is what's upsetting. To not see people even doing this. So that's why I lament 1, 2, 3, 4, 5. Don't care if I'm ruffling feathers. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 2 is 1, 2, 3, 4. We've got to buck up some of these things and do this. This is, and then here's another thing. How do I know I'm right? This passes the vertical line test. Those that have been crashing graphs all through each other, it's not a function. This is the function chapter. So everything has to be a function. So there's a discount double check to see that, all right, at least I have a reasonable answer. And I really should see, these, dots of plugins. Maybe not that one, but it would be nice. One more dot that still exists on our little coordinate plane provided. All right, good luck tomorrow.